All right, guys. Hey, it's Mrs. B again. We're going to be talking about an Algebra 1 topic today. It could be a pre-algebra topic, but it's primarily Algebra 1 and higher. We're going to talk about solving what we call multi-step equations, which means that we have more than just the basic mechanics of, get the constants together, get the variable alone, and divide both sides. So we got to take a few more steps than what we've been doing with the 1-step and 2-step equations. So what we're looking at here is we're going to maybe have to get rid of parentheses, distribute to get rid of parentheses, combine like terms, things like that. So our problems look a little bit more complicated, but they're still the same thing. Still the same ideas. So now let's look at what our rules are, or kind of what our procedures are as we go through this before we start some examples. So here are our basic procedures. And in our classroom, these are up on the wall for us to look at as we're working. So we'll put them up here at the top of our page for our notes purposes. The first step in solving any multi-step equation, or any equation, these are things you look for anytime, is the first thing we want to do is we want to do our distributive property. We want to get rid of all those parentheses, simplify it down as much as we possibly can. So we're dealing with individual pieces, like almost like little Legos that we're building into our building. Once we've distributed, then we want to combine our like terms. We want to make sure that we only have one of each thing on each side of the equation. So we're going to be combining like terms. Once we've combined the like terms, that's when we start doing what we did with the 1 and the 2-step equations. We're going to move things using addition and subtraction first. And then we're going to solve it by using multiplication or division. So it's still the same idea, still the same basic tenets. We want to get that variable alone. That's our final goal, is get that variable alone. We always want to do the opposite. We're moving something to the opposite side of the equation, so we need to do the opposite operation to get it there. And we got to think, this is like a scale. This problem has to stay balanced. It has to stay equal. So what we do to one side, we always do to the other side to keep that balance. So now let's look at our first example. 5y minus 8 equals 3y plus 12. So if I look at this, first thing, do I have parentheses in this? Nope, so I don't have to worry about that. Let's look, right-hand side. I have one with a variable and one without a variable, no like terms. Left-hand side, same thing, one with a variable, one without. So we've taken care of those first two. Now we want to look at moving things, because I'm not doing any good if I have a variable on both sides. So I want to take this 3y right here, and I want to move it to the other side. I want it to move it to the opposite side to be together with the 5y. So if I'm moving to the opposite side of the equation, I need to do the opposite operation. So where this is a positive 3y, I'm going to subtract 3y to make it disappear. But I'm going to subtract 3y on the other side because I'm still trying to keep this a balanced problem. So now let's look at this. 5y minus 3y gives me 2y. I bring down the 8, and I don't just bring down the negative 8, I just bring down the 8, I bring down a negative 8, because that minus sign in front of that 8 travels with it through the whole problem. 3y minus 3y gives me 0, it goes away. I haven't done anything to that plus 12, so it comes on down. But it's a positive number, so does it need that plus in front of it? Not usually, so I'm just going to let that go away because we have an understanding in math. If it's just a number by itself and there's nothing in front of it, it's a positive number, so we can treat it that way. Now let's look at this. We got 2y minus 8 equals 12. Do I have this variable isolated yet? Do I have this variable alone? No. And I've got a constant on each side. So this negative 8 wants to jump across to the opposite side to be with that 12. So since it's a minus 8, I'm going to add 8 to both sides so that it go to the opposite side with the opposite operation. The 2y is going to come down because I didn't do anything to it. Negative 8 plus 8 is 0, so that goes away. It equals 12 plus 8, which is 20. Now I'm closer to being done. I almost have the variable completely alone, but it says 2y, which means 2 times y. Well, I don't want 2y, I just want y. So the opposite of multiplication is division. So I'm going to divide both sides by 2 so that I can get that y by itself. Now 2y divided by 2 is y. 20 divided by 2 is 10. And now I have figured out that if I take 10 and I put it in both these spots and solve this out, I'm going to get two sides equal. So I have found out that the missing piece in this problem is 10. Now I'm going to put one up for you. What I want you to do is, after you write this problem down, I want you to pause your video, and using the example that we've already done, I want you to try and work the new problem, okay? Negative 6x plus 14 equals 12 minus 8x. Okay, so pause your video, work through the problem. When you finish working through the problem, start the video again, and I'll explain the work we've done. So let's look, let's go through our steps. Do I have parentheses here? I don't. I've got negative 6x plus 14 equals 12 minus 8. I don't have like terms. If I look here, I don't have a like term there or there. So now I'm ready to start moving things across the equals. I'm a person, I kind of like routine. Math teachers are like that. That's just kind of how we are. And I like to work things so that my variable is on my left. I don't care necessarily about the positives and negatives because those are going to work themselves out at the end. But kind of as the way I work things and the way I'm comfortable, I like having my variables on the left. So I'm going to take this minus 8 and I'm going to move it to the opposite side of the equation so that it can be with the other x, which is minus 6. But because I'm going to the opposite side of the equation, I'm going to do the opposite operation. So negative 8 becomes plus 8. And it gets done to both sides of the equation to keep it balanced. So now now that's just done, let's do the math. Negative 6x plus 8x. Negative 6 plus 8 gives me a positive 2x. The plus 14 comes straight down because I didn't do anything to it. The 12 comes straight down for the same reason. Negative 8x plus 8x goes away, so that becomes 0 and it disappears. Now, do I have everything together? Not quite. I have a coefficient, I have a constant here and a constant here. And I'm trying to get this x by itself, so I'm going to take this 14, I'm going to move it to the opposite side of the equation so that I can get this x to being closer by itself. So since this is a positive 14, I'm going to subtract 14 because I'm going to the opposite side of the problem. So I want to do the opposite operation to move it. 2x comes straight down because I haven't touched it. Positive 14 minus 14, that gives me a 0, makes it disappear. 12 minus 14 gives me negative 2. Now, this variable is almost completely alone. It's not there yet, but it's really close. I've got 2x equals negative 2. 2x means 2 times x. When we're doing opposites, and the opposite of multiplication is division, so I'm going to divide both sides by 2 and end up with x equals negative 1, because the 2's cancel here and here. So far, so good. Not too complicated, really close to what we did in our one-step and our two-step videos. So now let's look at another one. See, we'll throw another step in here. 3 times the quantity, 6p minus 1 equals 11p minus 45. Okay, so things have changed up a little bit here. I've got parentheses here. What does that mean for me? Well, that parentheses means that I've got to do some distributive property so that I can get rid of this and so that I can have little individual chunks to work with that are easy to move. So I'm going to do 3 times 6p, which gives me 18p. And then I'm going to do 3 times negative 1, which gives me negative 3. And that equals 11p minus 45 because there was nothing to change over here. Once I have that, I can start Does this problem now look like the two problems above it? It does. So now I can start with my steps again, trying to get my variables together and my constants together. So now what I'm going to do is I'm going to move this 11p to the opposite side. So I'm going to subtract 11p from both sides so I keep it balanced. 18p minus 11p is 7p. Now, not only do I bring the 3 down, but I bring that subtraction sign in front of it down as well. 11p minus 11p is 0. And then this 45 comes down, but it has that minus sign attached to it. So actually minus 45 is what's brought down. Am I to where I need to be? Not yet, but I'm really close. I've got the variable almost by itself, but I still have a constant on each side. So this minus 3 needs to go to the opposite side. So now instead of subtracting 3, I'm going to add 3 because I want to do the opposite. And I want it to do it to both sides to keep it balanced. The 7p comes straight down. And those cancel out. So now I have 7p equals negative 45 plus 3. That's like owing $45 and paying somebody $3. You still owe them $42. You'll get there eventually, but you still owe it. Now, am I finished yet? Is this variable completely by itself? Not quite. This still says 7 times p. So I'm going to divide both sides by 7. To make that, so those 7s go away and leave the p behind. Negative 42 divided by 7 is negative 6, and now I'm finished with my problem. I've gone through my whole process, and I found out that the number that needs to go in here for p to make everything work out is negative 6. So let's look at another example of this. Add another layer of complication. But no matter how complicated it gets, have I changed my basic ideas and my basic mechanics behind each problem? I haven't. I'm still asking myself the same questions and still following through with those same thoughts and processes. So now I have 2 times 4w minus 1 equals negative 10 times w minus 3. And then with a plus 4 tacked on the end. So we've added several layers here. We're still going through the same process. What's the first thing I look for? Do I have distributive property? Do I have parentheses that I need to deal with first? I do. So I'm going to take care of that. 2 times 4w is 8w. 2 times negative 1 is negative 2. 10 times w is negative 10w. Negative 10 times negative 3 is positive 30. Then I have a little plus 4 hanging out on the end. All right, so now let's look. Do I have any more parentheses? No, I don't. So now I've done my distributive. Now let's look at my combining like terms. Over here, I've got 8w minus 2. No like terms there. But on the other side, I have negative 10w plus 30 plus 4. Well, that plus 30 plus 4 are like terms. That 30 and that 4 are like terms, so I need to put them together. I'm going to write down what I don't change. And I'm going to look at, well, 30 plus 4 is 34. Now my problem looks like every other problem I've worked so far. So I'm going to take it, I'm going to get my variables together. That means this minus 10w has to come across to the opposite side of the problem to join the 8w. So instead of subtracting 10w, I'm going to add 10w because that's the opposite operation. And I'm going to add it to both sides to keep it balanced. 8w plus 10w is 18w. Minus 2 equals, well, negative 10w plus 10w goes away and leaves the 34. Looking more and more like we're used to doing. This minus 2 is still attached to the 18W and needs to move to the other side to be with the other constant. So I'm going to add 2 to both sides because I'm using that opposite side, means opposite operation. Excuse me just a second, guys. Technical issues are our friends today, it appears. Give me just one second. All right, see, are we still going? Okay, sorry about that, guys. Switch some plugs around, so we're almost done now. Sorry about that. 18W plus 2, sorry, minus 2 plus 2. So that leaves the 18W, because those go away. 34 plus 2 is 36. We're almost there. The variable's almost by itself. So let's look. 18W equals 36. 18 times W equals 36. Do the opposite. So I'm going to divide by 18. So W equals 2. A whole lot of work, but it's done. That's what we needed. Okay. Now what I'm going to do is I'm going to give you one to try on your own. Actually, I'm going to give you 2 to try on your own. They're going to be a little more complicated than the 4 we've done together. But it's time to start stepping up your game. I want you to take what we've done with these 4 problems and apply it to the next 2 problems. Okay, so let's look at what we've got here. I'm going to give you 2 problems. 9 times m minus 3 equals, oh, sorry, forgot plus 3 equals 7m plus 43. And then 8 times y plus 4 minus 2 times y minus 1 equals 70 minus 3y. And I almost ran out of room here. So what I want you to do is I want you to write these 2 problems down on your page, pause the video, work these 2 problems, then start the video again and compare your work to mine and see if we come up with the same answers. So now let's check our work. Steps to think about. I've got to check for distributive property. Then I've got to check for like terms. And I'm just going to put CLT for combined like terms. Then I'm going to use moving addition and subtraction, and I'm going to solve using multiplication and division. I want that variable alone. I want to do opposite operations to get it that way. And I want to keep things balanced by doing the same thing to each side of the equation at every step. First things first. Do I have parentheses? I do, so I've got to do my distributive property. 9m minus 27 plus 3 equals 7m plus 43. Remember, you always write down anything you don't change, okay? And only try and change one thing between each step, or do one set of thinking between each step. Now let's look at this. Do I have any more parentheses? No, I've gotten rid of all of them. Do I have like terms? 9m minus 27 plus 3. Like terms right there, okay? So that becomes 9m minus 24 equals 7m plus 43. All right, I'm done combining my like terms. There's nothing like term-wise between either side. So now I can start moving things to get my variable, so I can better get my variable alone and keep my problem balanced. I have an m on both sides, so this 7m is going to come to the opposite side to join the 9m. and I'm going to subtract 7m from both sides because I want to do the opposite operation to move it to the opposite side. 9 minus 7 is 2, so I got negative 2m minus 24 equals, well, those cancel out, equals 43, because 7m minus 7m is 0. Is everything still, do I need to move anything else? Am I ready to divide? Nope, I still have a constant on each side. So I'm going to move this minus 24 to the other side. The opposite of minus 24 is plus 24. So now I have 2m equals 67. I am almost there. The variable is almost completely alone. So now what I'm going to do, 2m means 2 times m, so I'm going to divide both sides by 2 and get that m equals 33.5. And you can double check this on your calculator, but 2 goes into 6 3 times, 2 goes into 7 2 times, leaving 1 behind, and then I have 2 goes into 10 5 times. That's how I got that. Right. I'm gonna run out of room here if I try, so I'm gonna rewrite it. I've got 8 times y plus 4 minus 2 times y minus 1 equals 70 plus 3y. Okay, start our process all over again. Do I have distributive property? Do I have parentheses to get rid of? I actually have it twice. Here, 8 times y and 8 times 4, and negative 2 times y, and negative 2 times negative 1 equals 70 plus 3y. So now I have 8y plus 32 minus 2y plus 2 equals 70 plus 3y. Awesome job. But do I have like terms? Do I have things that need to go together? Well, let's look at the left-hand side. I have an 8y and a minus 2y. Those are like terms that need to go together. 8 minus 2 is 6. Look at the other two pieces I have left. Plus 32 plus 2. So those are like terms, and they need to put together. 32 plus 2 is 34. And it equals 70 plus 3y. Now, this looks pretty much like what we started with at the beginning of this lesson. Variable plus a constant equals variable plus a constant, or something along those lines. I need my variables together. So this plus 3y needs to go across to the other side. So I'm going to subtract 3y from both sides. Keep it balanced. 6 minus 3 is 3, so 3y plus 34 equals 70. Well, 3y minus 3y is 0, so that goes away. Now, still don't have my constants together, so that plus 34 needs to come to the other side, which means I'm going to subtract 34 from both sides. So now I have 3y equals 70 minus 34. Well, let's see, 10 minus 4 is 6, 6 minus 3. So there we go, 3y equals 36. Now I'm going to divide both sides by 3 because I'm still doing my opposite, still trying to get my variable alone. And y is going to equal 12 because 36 divided by 3 is 12. Now, these are probably the most complicated problems we'll run into in terms of solving equations. If you can solve a one-step and a two-step, you can solve a multi-step. You just have to take it piece by piece. Go to Google, go to DuckDuckGo, whatever you need to, and Google practice problems for solving multi-step equations. Use your notes, practice this. If you have any questions, leave me comments. I'll see what I can do to help. Thanks for joining me, and keep practicing.